Hi, today we're going to go over the homework problem number 3. So before you watch this video, please make sure that you try it and come back to your well for you. We are trying to minimize the salary costs. So therefore my objective function is going to be the costs. And based off of that, we need to know how many teachers and teachers' aides. So that's going to be what our x and our y is. So x is number of teachers, and then the y is going to be the number of the aides. And so now looking back, to minimize our costs, we have the different salaries given to us. So we have 35,000 per X and 18,000 per Y. Now you go through and you look for other totals. So I see 50 is a total that we're going to need to talk about, 20 is a total that we're going to need to talk about, and then also this 12. So if we need no more than 50, that means 50 is going to be whatever x and y are together. We need a minimum of 20, so we want x plus y to be greater than 20. We have to have at least 12 aides. Now that one is specific to your y value. So y by itself has to be at least 12. X also has to be at least 0 just because we're not going to have any negatives here. So you have to have at least 0 for X. Now we have one other thing in here that we haven't actually written an equation for. Reading through, we have almost all of the information except for this one right here. The number of teachers must be at least twice the number of aides to accommodate the expectations of the community. So the teachers has to be at least, meaning it's more than or equal to, twice the aides. So we're going to show twice whatever y is, bigger than that. You can scale your want. I don't know. So my first equation here, I'll graph this one in purple. We have x plus y is less than 50. So 0 comma 50 is going to be my y-intercept, and 50 comma 0 is going to be my x-intercept. And so I can go ahead and take those and connect them. This next one I'll graph in blue. So 0 comma 20 is going to be my y-intercept, and 20 comma 0 is going to be my x-intercept, and then I can connect those. So right now for shading purposes for the purple, we're looking for everything less than that. And if you plug in 0, 0, that would work. So for purple, we're supposed to shade below, whereas blue, you're looking for the bigger portion. So right now we're supposed to shade above blue. So we're looking for everything in between the blue and the purple. So let's go ahead and look at this next one. The y is greater than or equal to the 12. So that's going to be a horizontal line across at 12 on my y values. And we're going to look for everything above that to be shaded. X is greater than or equal to 0 is going to be the vertical line through 0 and everything to the right. So then we just have that one last one. X is bigger than or equal to 2y. I'm going to solve for y by dividing by 2. And be careful with this. If you're looking at your inequality, it's actually y is less than or equal to 1/2 x. And so what we can do is we can go to 0, 0. We can go up 1 and over 2. Even though our scale here is not exactly 1 to 1, like our x values are scaled the same as your y values. So we're technically going up 5 and over 10, which reduces to 1/2 anyways. So now for shading for that green line, we have to be careful here. So we can't plug in 0 comma 0. So let's pick a different test point. Let's test 10, comma 0. So if I plug in 10 for x, I'm going to go back to my original equation. I get 10 is greater than or equal to 2 times 0, which is true. So I want everything below that green line because it encompasses 10, comma 0, which means my feasible region is going to be this little triangle here inside there. So if I were to trace my feasible region, I have 1, 2, 3 intersection points that I'm going to need to come up with. The first two are on that horizontal line for y, which means my y value has to be 12 for both of those. For this first, if my y value is 12, what I plug 12 in for y, 24. For the next one, my y value is 12. This is my intersection of my orange and my purple. I can go ahead and plug in 12 for my y value in my purple equation, which was the x plus y is less than 50. And if I solve that for x, I get x is 38. And my last one is the intersection of the purple and the green. So I'm going to go ahead and I'm going to use my highlighter. My purple is this one, my green was this one. So I'm going to solve this one algebraically. You can solve it different. We have x equals 2y and x plus y equals 50. We're looking for that intersection point of those two to find that last vertice. So I'm going to go ahead and plug in 2y for x. I'm using substitution. And if I do that, I get y equals 50 thirds. By plugging in 50 thirds, I would end up with x being 100 thirds. Now, if you're looking at this and saying, well, okay, that makes sense for an intersection point, but that does not make sense for people, you would be absolutely correct. So this first one is saying, like, I have 33.3 people. That doesn't work. And the next one would be saying I have 16.6 repeating people. That doesn't work. So what we're going to do is we're going to go, and this one, we have to be in the feasible region, so we can't just use our normal rounding methods. We're going to make sure that we're going to look at where the closest point in the feasible region would be. So we're actually going to use the point 33, comma 16. So then you're going to plug these in for your x and your y value for your objective function. So you're going to be doing 35,000 times 24 plus 18,000 times 12. So 24 comma 12 gives you 1,056,000 for your cost. Next one, you plug in 38 and you plug in 12, you're going to get 1,546,000 for your operating costs. And the last one, we plug in 33 and 16 to get 1,443,000 for your cost. And this one was looking to minimize your costs. So of all of these ones, the minimum value is that 1,056. So we should hire 24 of our X's, which was our teachers, and 12 aides to minimize the cost at the 1,056,000. Thank you very much for listening.